Imagine looking across hundreds of kilometers of desert and suddenly seeing a modern city. Roads, apartment towers, factories, airports, millions of people living where almost nothing naturally grows. The obvious question isn't, how did China build these buildings? It's much harder than that. Where did the water come from? Because in the desert, before you can build a city, you have to build the system that makes the city possible. China's desert cities are not simply collections of buildings. They are enormous infrastructure systems designed around one fundamental problem: water. Engineers had to move, store, clean, recycle, and distribute water across extremely dry environments. Then came roads, electricity, housing, industry, and transportation. The buildings were only the visible layer. The real megaproject was hidden underneath. Building a skyscraper in a desert is relatively straightforward. Building a functioning city is not. A city needs drinking water. It needs water for sanitation, industry, landscaping, agriculture, and emergency services. But many of China's arid regions receive only limited rainfall, and evaporation can remove water extremely quickly. That means engineers cannot design the city around natural rainfall alone. They need a controlled water system. The first step is identifying reliable sources. Depending on the region, water can come from rivers, reservoirs, groundwater, long-distance transfer systems, and increasingly, treated wastewater. Once a source is available, the next challenge is moving it. Water may need to travel dozens or hundreds of kilometers before reaching the urban area. That requires pumping stations, pipelines, reservoirs, treatment facilities, and carefully controlled distribution networks. But moving water consumes energy, and pumping uphill or across long distances can become extremely expensive. So engineers design the entire network around elevation, pressure, storage capacity, and demand. Large reservoirs can store water during periods of higher supply and release it when demand increases. Treatment plants then convert raw water into a form suitable for human use. And after people use it, the water doesn't necessarily become waste. Modern desert cities increasingly rely on wastewater treatment and reuse. Water from homes, industries, and municipal systems can be treated and redirected for purposes that don't require drinking quality water. This creates a critical engineering principle. Don't use valuable fresh water once and throw it away. Instead, capture it, treat it, reuse it, and repeat the cycle. But even with an engineered water network, the desert presents another problem. The ground itself can work against the city. A desert isn't just dry, it's constantly moving. Strong winds can transport enormous quantities of sand across the landscape. If a new city is built directly in the path of shifting dunes, roads, buildings, pipelines, and power infrastructure can all become vulnerable. So engineers first have to control the ground around the city. One method is vegetation. Plants can stabilize loose soil by creating root networks that hold the surface together. But planting vegetation in an extremely dry environment creates another problem. Where does the water come from? This is why desert landscaping is not simply about planting trees. Engineers have to select species capable of surviving local conditions and design irrigation systems that deliver water efficiently. Instead of flooding large areas, controlled irrigation can deliver water directly to the root zone. In some locations, treated wastewater can also be used for landscaping and ecological projects, reducing pressure on freshwater supplies. Engineers can also use physical barriers and carefully plan landforms to slow the movement of sand. Roads and critical infrastructure are positioned to reduce exposure to major dune movement. The objective isn't to completely defeat the desert. That's impossible. The goal is to manage its movement. And once the surrounding environment becomes more stable, engineers can build the infrastructure a city depends on. Roads, power lines, pipelines, drainage systems, and eventually, buildings. But all of these systems share one hidden dependency. They require enormous amounts of energy. And in the middle of a desert, generating and delivering that energy becomes another engineering challenge. A modern city cannot survive on water alone. It also needs electricity, air conditioning, water pumping, factories, street lighting, transportation, and thousands of buildings operating simultaneously. In China's desert regions, engineers faced a difficult combination: huge energy demand and an environment with extreme temperatures. During summer, temperatures can rise dramatically, increasing the demand for cooling. That makes reliable electricity essential. One major advantage of desert environments is something they have in enormous supply: sunlight. Large solar installations can use vast areas of open land to generate electricity. But solar power creates another engineering problem. The sun doesn't shine continuously. Electricity demand, however, doesn't stop when the sun goes down. So engineers need systems that can balance generation with demand. Power can be transmitted from large renewable energy facilities toward urban areas through high-voltage transmission networks. Energy storage can also help shift electricity from periods of high generation toward periods of higher demand. And the city's infrastructure itself can reduce energy consumption. Buildings can use insulation, reflective surfaces, efficient cooling systems, and carefully designed ventilation to reduce the amount of electricity required to maintain comfortable indoor temperatures. The result is a larger system where energy generation, transmission, buildings, and water infrastructure all interact. Because there is a hidden connection between them. Moving water requires energy. Pumping water across long distances can consume enormous amounts of electricity. So the city's water network and power network cannot be designed independently. Engineers have to optimize both. The desert may look empty from above, but beneath the surface, an enormous infrastructure network is constantly moving water, electricity, people, and materials. And then comes the next challenge. Before a desert becomes a city, it needs connections. Roads have to cross enormous distances with almost no natural landmarks. Railways must maintain stable foundations despite extreme temperatures. And airports need reliable access to surrounding communities. Building roads across desert terrain creates problems that don't exist in ordinary urban construction. Sand can shift beneath pavement. Extreme heat can affect road surfaces. And long distances increase maintenance requirements. Engineers therefore study soil conditions before construction and design foundations capable of handling local ground movement. Where dunes threaten infrastructure, protective systems can reduce sand accumulation around roads and railways. Drainage is another important consideration. Deserts may receive little rainfall most of the year, but when intense storms arrive, enormous amounts of water can move through normally dry channels. Urban drainage systems therefore have to handle sudden flooding without sacrificing everyday efficiency. Railways create another engineering challenge. A high-speed railway needs extremely precise geometry. Even small changes in the foundation can affect track alignment. So engineers use reinforced foundations, carefully controlled embankments, bridges, and viaducts where necessary. But transportation isn't only about moving people. It also moves the materials required to build the city itself. Steel, concrete, glass, machinery, fuel, food, and construction equipment. Without reliable logistics, a remote desert development becomes dramatically more expensive. That is why transportation infrastructure often arrives before the city fully exists. First comes the connection, then the utilities, then the buildings, and eventually, the desert begins to look less like empty land, and more like an extension of the national infrastructure network. But even after roads and power arrive, one question remains. A city in the desert can't simply copy the design of a city in a cooler climate. The buildings themselves have to fight the environment. Extreme heat increases cooling demand. Dust can reduce air quality and damage equipment. And intense sunlight can turn exposed surfaces into heat reservoirs. So engineers use the buildings as the first layer of defense. Insulation reduces heat entering from outside. High-performance windows limit unwanted solar gain. Shading systems reduce direct sunlight before it reaches interior spaces. And efficient cooling systems reduce the amount of electricity required to maintain comfortable temperatures. Urban layout matters too. Buildings can be positioned to create shaded pedestrian routes and reduce exposure to direct sunlight. Roads, sidewalks, and public spaces can use materials selected to handle extreme heat while remaining durable. But creating a comfortable city isn't only about individual buildings. Engineers also have to manage the heat produced by the city itself. Air conditioning systems release heat into the surrounding environment. Vehicles and industrial facilities generate additional heat. Large paved surfaces absorb solar energy throughout the day, so planners can introduce vegetation, shaded areas, reflective surfaces, and carefully design public spaces to reduce localized heat. Water also becomes part of the urban climate strategy. But in a desert, every drop has a cost. That's why irrigation systems must be carefully controlled and wastewater increasingly becomes a resource rather than something simply discarded. The goal is not to turn the desert into a tropical landscape. It is to create a controlled environment where people can live efficiently within the climate. And once the city becomes physically comfortable, engineers face an even larger challenge: keeping millions of systems connected and functioning together. When people look at a desert city, they see towers, roads, and highways. But the most important infrastructure is often invisible. Beneath the streets are networks carrying water, electricity, communications, drainage, and wastewater. These systems must be planned before the buildings above them are constructed. Water pipelines need controlled pressure. Sewage networks need carefully calculated gradients. Electrical cables require protection from heat and physical damage. Stormwater systems must be prepared for sudden rainfall events, even in places where rain is normally rare. And everything has to remain accessible for maintenance. This is where modern urban engineering becomes less about individual structures and more about systems. A city is essentially a giant machine. Water enters, wastewater leaves, electricity enters, heat is generated, people move through the network, goods arrive, and information travels continuously. In a desert environment, inefficiency becomes expensive. A leaking pipeline wastes scarce water. An inefficient building consumes additional electricity. A poorly designed road creates transportation problems. So engineers increasingly use sensors and centralized monitoring systems to track infrastructure performance. Water pressure, electricity demand, temperatures, and equipment conditions can be monitored in real time. This allows operators to detect problems before they become major failures. And that is what makes these cities possible. Not one giant engineering breakthrough, but thousands of connected systems working together. The desert may appear empty from the surface. Underneath, it can contain one of the most complicated infrastructure networks humans have ever built. And that leads to the biggest question of all. Can these cities remain sustainable as they continue to grow? A desert doesn't naturally provide what a modern city needs. Water is limited. Heat is extreme. Sand moves. And distances are enormous. Yet across China's arid regions, engineers have built cities by replacing natural advantages with infrastructure. Water is transported. Wastewater is recycled. Energy is generated and transmitted. Buildings are engineered for heat. Roads and railways connect remote regions. And beneath everything, a hidden network keeps the city alive. The remarkable part isn't that China built buildings in the desert. It's that engineers built an entire urban ecosystem where almost nothing was naturally available. The desert wasn't removed. It was engineered around. And that may be the most important lesson. Modern megaprojects aren't always about conquering nature. Sometimes, they're about building a system capable of surviving where nature never intended a city to exist. This is Echoes of Power,